Hey everyone, today's lesson is going to be about one variable equations. All right, I've got the Springboard book pulled up on my computer here for lesson 1.1, one variable equations. So basically, we're going to be creating equations from one variable and then solving them. So this question has to do with the water park. I'll go ahead and read it real fast. A new water park called Sapphire Island is about to have its official grand opening. Staff is putting up signs to provide information to customers before the park opens to the general public. Read the following scenario, blah, blah, blah. The Penguin, one of the park's tube rides, has two water slides that share a single line of riders. Ugh. The table represents information about the number of riders and the tubes that can be used in each slide. All right. Jabir places a sign in the waiting line for the Penguin. When a rider reaches the sign, there will be about 100 people in front of him or her waiting for either slide. Ugh. The sign states from this point your wait time is about blank minutes, and Jabir needs to determine the number of minutes to write on the sign. Jabir's got an interesting job for working at a water park. All right, so let's look at our first task. Let the variable r represent the number of riders taking slide 1, okay? Write an algebraic expression for the number of tubes this many riders will need, assuming each tube is full. So if we look at the table under tube size right here, so this one tube can apparently hold two people. So I guess it's like a figure eight looking thing. My guess is maybe it looks like that, but prettier. Simply, the number of riders would be right here divided by 2, because 2 people can fit inside this tube, right? So it says next, write an expression for the time in minutes it will take n riders to go down slide 1. So we're going to keep our expression for the number of riders taking it, which was r divided by 2. Now we need more information. We need to know about the time in minutes. So let's go back to our table. It says tube release time. And the tube release time for slide 1 is every 3/4 of a minute, every 0.75 minutes. So we're just going to take that and stick it on our expression, 0.75. So there is our expression for the time in minutes it will take r riders to go down slide 1. So far, so good. All right, our next task. Assuming that r riders take slide 1 and there are 100 riders in all, write an expression for the number of riders who will take slide 2. Okay, so we have 100 riders in all. Okay, and the people that will take slide 2 are the ones that did not take slide 1? Question mark? That seems kind of a silly question, but logically it's the number of people minus the people that already took slide 1. Not too bad. All right, what's our next task? Number 4. Let's see. Using the expression that we wrote in item 3, write an expression for the number of tubes the riders taking slide 2 will need, assuming each tube is full. So let's go back to our table and look at tube size for slide number 2. This case, it's 4 riders. So I guess it looks like a clover, maybe? I don't know. I like to visualize things. I'm thinking maybe it looks like, yeah, a clover. I hope you're really good friends with your friends. You're going to be that awfully close to each other. Anyway, so task number 4, we're going to take the people who are on slide 2, so that 100 minus r, that's the number of people that are in slide 2, right? Divided by the number of people that can fit in a single tube. So 4 people can fit in a tube, right? Pretty easy. All right, number 5, write an expression for the time in minutes needed for the riders taking slide 2 to go down the slide. This is pretty much exactly like what we did before. So we're going to keep our expression we just wrote, that 100 minus r divided by 4, right? So that's the number of people that are going down the tube. And then we're going to use our time. So let's go back to our table. And it says tube 2, or slide 2, launches a tube every 1.25 minutes. So we're going to say, okay, every 1.25 minutes, and I'll put that back down there. Cool, cool. All right, number 6. Jabir. Jabir wants to know how long it will take for 100 riders to complete the ride when both slides are in use. The total time for the riders taking slide 1 should equal the total time for the riders taking slide 2. Write an equation that sets your expressions equal. Well, okay. So our first expression was r divided by 2. Let me double check. R divided by 2 times 0.75. Times 0.75. Cool, cool. And then our second expression was 100 minus r divided by 4 people in the tube every 1.25 minutes. All right, done. Easy breezy, beautiful math. All right, number 7, reason abstractly and quantitatively. Solve your equation from item 6. Seems easy enough. What I would do here would be to clear the fractions. I would simplify because I don't like having fractions when I'm doing my math. So I'm going to multiply. I unfortunately here in my home studio do not have the really cool Inspire pop-up software that I can put on my computer so I can show you what I'm typing in. So I'm just going to tell you. I already put this in a calculator. So 0.75 3/4 divided by 2 is going to be here we go 0.375 r, and then the other side is going to be 100 minus r, and then 1 1/4 divided by 4 is 0.3125. So that's my step 1. My step 2 would be use the distributive property, so I can take this 100 and multiply it times this guy, and then my r and multiply it times that guy. Or the other way is the same thing. It just happened to be that way, and I like drawing to the left. So I'm going to keep my 0.375 r, and then 100 times 0.3125 is 31.25 minus 0.3125 r's. All right. Now what we can do is collect like terms. So I'm going to add the smaller value, this 0.3125. So plus 0.3125 r's. We're going to say plus 0.3125 r's. Excuse my little brain fart there. These guys cancel out, and we end up with 0.6875 r's is equal to 31.25. And I had a bit of a brain fart right there for a second because I'm not being super awesome, and I should have lined up my decimals a little better when I was working. So I was like, wait a minute, but I got it. All right, now all we have to do is divide by that 0.6875. Whew, this is getting long, isn't it? Go ahead and divide by 0.6875. Divide by 0.6875, and we get that one rider takes, well, we're gonna estimate here, 45.5. Goodness gracious. All right, so what does that actually mean? R is number of what? Riders. So let's I would be uncomfortable having half a person as a rider. I don't know about you. So I think that perhaps rounding up to the next whole number is the kindest thing. If we can fit half a person, we can certainly fit a whole person. Yeah. Would it be half vertically or would it be half horizontal? Anyway, round up. We are not cruel. So we should totally round it up because we don't like killing people. Portions of riders don't make sense. Portions of riders don't make sense. Gross. How many people of the 100 will then take slide 1? Well, 45 and a half rounded up is going to be 46 people. We'll end up taking slide 1. Use the expression that we wrote in item 2 to determine how long it will take number of riders from item 8b to go through slide 1. So basically what we're going to do is plug in, what we knew, which we said r divided by 2 times, what was that number? 0.75, 0.75, except we're going to replace the r with 46. So 46 people divided by 2 times 0.75, which equals bada bing, 17 and a quarter. And this would be minutes, right? And I know that because we were saying that a tube launched every 3/4 of a minute. So it's going to take 17 and a quarter minutes to go through slide 1. If we round to the nearest minute, that's about 17 minutes. Geez, Mr. Clark, learn to spell. All right, so that means that if we have our 100 people in line, both slides are going, given the information in the table, that slide 1 will be cleared out in about 17 minutes. Goodness. All right, so let's look at the next part. The rest of the 100 riders will go through slide 2 in about the same time. So use your answer to item 9b to give an estimation number of minutes it will take all 100 riders to go down penguin slides. Well, 17 if they're taking the same amount of time, right? I mean, it says right here, about the same amount of. Why am I not highlighting? It says right here, about the same amount of time. So yeah, that worked. 2 for 1. I like that. Hashtag I'm lazy. All right, let's look at number 11. This is always my favorite, and I think one of the most important things you can do in solving a math problem. How can we make sure that our solution is reasonable? In this case, we really could just substitute r back in and see if the equation is true, which it clearly is since we solved it. You could also take your solution here, the 17, and plug it in for slide 2 and see if that's correct. You could do the same thing for the number of riders that should be going through it and see if you get that same approximate time. So there's a couple ways we can do it, and I think that the easiest way would probably be to take the other 54 people, plug them in, and see if we get about 17 minutes as well.